Okay guys, let's recap back the assumptions of Hardy-Weinberg. For the generation to remain constant, um, as long as these assumptions that you see on the slide are met, so there's no genetic drift, there is no random mating, uh, sorry, there is no random mating pula. There is a random mating, there is no natural selection, there is no mutation, there is no migration. So if all of these assumptions are met, then the allele frequencies and the genotype frequency will remain constant. So ini adalah assumptions untuk Hardy-Weinberg equilibrium. For the frequencies to remain constant, all of these assumptions have to be met. Okay, met to be Hardy-Weinberg equilibrium. So the Hardy-Weinberg equilibrium is a principle stating that the genetic variation in a population will remain constant from one generation to the next generation in the absence of disturbing factors. So what are the disturbing factors? These are the disturbing factors. Faktor yang boleh mengganggu perubahan frekuensi. So kalau tak ada semua ni, tak ada mutation, tak ada selection, tak ada genetic drift, then the population will be at Hardy-Weinberg equilibrium. So when mating is random in a large population with no destructive circumstances, the law predicts that the both genotype and allele frequency will remain constant because they are at equilibrium. Let's look into this assumption one by one. So a large breeding population means that the chance alone does not disrupt the genetic equilibrium. Okay, because the population is very large, any genetic drift that occurs in that population can be negligible. Okay, but in a small population, so in comparison to a small population, only a few copies of certain allele may exist. So if for some chance reason that the organism with the allele do not reproduce successfully, the allelic frequencies will change. So this random non-selective change is what happened in genetic drift or in a bottleneck event, something that we will look into after this. Okay, so just remember, genetic drift will not affect a large population sebab it's negligible, but if it's a smaller population size, tak banyak allele gene pool dalam tu, so a small changes can affect then the frequencies of the allele, so in a smaller population. Okay, so you can say that Hardy-Weinberg equilibrium may work well with large population, but not so well for a smaller population. Okay, random mating. In a population at equilibrium, mating must be random. In assortative mating, individuals tend to choose mates similar to themselves. For example, large blister beetles, they tend to choose mates of large size, and the small beetles tend to choose their partner smaller size jugalah. So yang small nak dengan yang small, yang large dengan nak yang large size. So this is a non-random mating bila dia ada preferences. Okay, when individuals have preferences of what their partner should be, then it's no longer random. Itu dah kira non-random. So untuk random mating, like for untuk Hardy-Weinberg equilibrium, you cannot have preferences. You random lah, tak ada faktor yang menyebabkan you kena kahwinkan dengan orang tu ke apa ke, you just terima seadanya. Just okay, macam tu lah. Random mating does not necessarily alter allelic frequencies, but it does result in a fewer heterozygous individuals that you would expect in a population that should be random. Yes, the mating, right? So again, random mating, there should be no factors that cause you to choose the mates or the partners. Okay. So bila ada preferences macam kumbang tadi, kumbang yang kecil dengan yang kecil, yang kumbang yang besar nak yang besar, dan itu dah non-random mating. Now, no natural selection. In a population at equilibrium, no alleles are selected over other alleles. Maksudnya semua sama. If selection occurs, those alleles that are selected for will become more common. So kalau berlaku natural selection, selected alleles yang terpilih akan jadi lebih common. Sebabnya yang alleles yang kita tak nak tu, dia takkan jadi common lah, sebab kita tak nak dia kan. For example, if resistance to a particular herbicide allows weeds to live in an environment that has been sprayed with that herbicide, the allele for resistance may become more frequent in that population. So obviously they are gonna prefer the resistance allele to the herbicide because they also want to survive, right? So this is natural selection, berlaku secara naturally. Resistant to occur secara naturally, and then it's being transfer passed to the offspring secara naturally, sebab they have to have the resistance early in order to survive the herbicide sprays, right? So that is natural selection. So if that happens, then the Hardy-Weinberg equilibrium will not condition will not be met, so the population is not at equilibrium. Okay, but if there is no natural selection, no alleles are being selected, all individuals are have the same level of reproductive advantages and disadvantages, so there is no natural selection, the population may remain constant. No net mutation just means there is no change in the allelic frequency due to mutation. Okay, no change in allelic frequency due to mutation. For a population to be at Hardy-Weinberg equilibrium, there can be no change in allelic frequency due to mutation. Any mutation in that particular gene or any other particular gene would change the balance of the alleles in the gene pool. Mutations may remain hidden. So again, in a large population, mutation can remain hidden, but for a smaller population, this mutation they can show quite significantly, right? If there is no mutation, the rate of forward mutation is the same as the rate of backward mutation. So no change in the organism DNA. Bila tak berlaku changes, there is no creation of new alleles, so the gene pool of that population won't be disturbed. So no disturbance to the frequencies means that the population is at equilibrium according to Hardy-Weinberg principle. But should there be any mutation, then there will be an introduction of new alleles into that gene pool. So the introduction of new gene pool, the frequencies will change, and the again it will not be at equilibrium. Alright. The last assumption would be the no migration means no immigration, no emigration. Maksudnya tak ada yang keluar, tak ada yang masuk. For the allelic frequency to remain constant in a population at equilibrium, no new alleles can come into the population and no alleles can be lost. Okay, sebab kita calculate genes and we also calculate alleles, so they should not be, if we want the population to remain constant at equilibrium, there should not be a new introduction of new alleles, and there should not be loss of alleles. So in terms of mutation kan, kita tak nak berlaku mutation because we don't want any introduction of new alleles. If the alleles or the genes of that the sequence of the genes change, means there is new allele, new unwanted alleles lah sebenarnya kan, sebab dia something yang kita tak nak. For example, so we don't want any net mutation. For in terms of migration, it's not because the introduction of new alleles and the loss of the old alleles is not because of mutation. It's just because the member in that population, they are moving from that population to another population, for example. Okay, so both migrate, whether you are going into a new population or people from other population is getting into your population, can alter the allelic frequency, sebab there will be a gene flow into or out from that population. Alright, but then if there is no gene flow in and out of this population through migration, then the population can remain constant. Okay, so that's about assumptions of Hardy-Weinberg principle.